Derivatives with natural logarithms, chain rule, my quick and easy method. So, we know that y, when y is ln x, derivative of y is 1 over x. Okay, so that's just the concept we'll be using today. The chain rule won't be formula. We won't be writing down anything. We'll be doing it as we'll be using the techniques from the chain rule as we do the question. So let's start. Example 1. Y equals ln 3x. So derivative, you start from your outside and work your way in. So same way we did the derivative when we follow the chain rule every other time. Derivative of the outside, which should just be ln of whatever's in the brackets. The derivative of ln is 1 over whatever's in the brackets, multiplied by the derivative of the inside. The inside being 3x, the derivative being 3. If we were to simplify this, we would have 3 on 3x, because we just multiply the 3 on top. And to simplify it further, we cancel out the 3's and have 1 on x. So the derivative of ln 3x is 1 over x. Another example. Let's say ln sec x. So, start our way outside just like before. The derivative of ln is 1 over, and what's in the brackets is sec x. And then we multiply that by the derivative of whatever's in the brackets. So the derivative of sec x is tan x multiplied by sec x. That's what it is. That sec x, the derivative of that, equals this. So we bring this on top, and we have tan of x multiplied by sec x over sec x. So now, because we have tan divided by sec is just tan divided by sec, but when you have sec divided by sec, you can cancel them out. So you're left with tan x. Technically it's tan x over 1, but no one bothers with that. They just write this. So the derivative of ln sec x is just tan x. Another example. Let's say we have y equals x squared plus ln x squared plus 3. So here, when we derive it, because there's a plus sign, we sort of focus them on, we can focus on them one at a time, or if there was a minus sign, we do the same. But in this case, this case it's the plus sign. So we'll start with x squared. The derivative of x squared is 2x plus, now we focus on this side. Derivative of ln is 1 over whatever's in the brackets, x squared plus 3. Multiply that by the derivative of whatever's in the brackets, and you're left with 2x. And you will plus 0, but you wouldn't write that. So if we simplify this, we're left with 2x plus 2x on x squared plus 3. And for another example, so we have y equals cosine of ln of ex plus x. Now I've done videos on trigonometric derivatives and derivatives with e. So if you don't know them, it'd be beneficial to watch them, or at least learn the techniques, because they're very important in differentiating. And not this particular question, but just in general. But on this question, we'll answer it. So the derivative, we'll start with the outside. The derivative of cosine is just negative sine, and whatever's in the brackets stays the same. Then we multiply that by the derivative of whatever's in the brackets, and that will the second function, which would be ln. So derivative of ln would be 1 over, and whatever's in the brackets of ln, which is ex plus x, e to the power of x plus x, and then we multiply that by the derivative of whatever's in the inner brackets, the third function, which would be the derivative of ex plus x would be ex plus 1, because the derivative of ex is just ex. So if we were to simplify this, we'll make it look at least a little neater. We'd have negative ex plus e to the power of x plus 1 in brackets, and then we'd multiply that by the sine of ln e to the power of x plus x all over e to the power of x plus x. That's because what I did here was I multiplied this to this end, which brought it out the front, and I multiplied this and that together, the whole thing, on top of this fraction. And this is what you get. See, this is how quick the easy method is. It's if you know how to do the chain rule, and you know how to use it, and you're proficient at it, it can be even quicker than this. But hopefully this video helped, and thanks for watching.